So suppose that we have two functions, f of x and g of x, and let's just suppose that f of x happens to be the larger function this time. F of x is the function on top this time. Take the region between f of x and g of x on this interval and spin it around the y-axis, How then can you find the volume of the solid of revolution? You can find it by integrating the surface areas of the cylindrical cross-sections. Each of the cylindrical cross-sections has a radius of just x and a height that is obtained by taking the difference of top function minus bottom function. Integrate this with respect to x from the lower limit to the top limit. Now once again, as a warning, if you're going to use this to do method of cylindrical shells to find the volume, you must absolutely make sure that the independent variable of your functions and the variable of your axis are mismatched. You want them to be different this time. The independent variable of your functions must be different from the variable of the axis, So let's see an example of this formula at work. Let's consider the triangular region bounded by the lines f of y equals 1/2 y, the line y equals 0, and the line x equals 2. So here we go with the drawing. Here is x and y. X equals 2 is a vertical line 2 units along the road. So here is x equals 2. Y equals 0 is the x-axis, so I'll sketch that in blue. Y equals 0. And here comes, in green, we will have f of y equals 1/2 y. Or, if that's a little bit tough for you to draw, instead of having x equals 1/2 y, you may prefer to think of this as y equals 2x. It may just be a little bit easier and more familiar to you to graph it if you think about this as y equals 2x instead of as x equals 1/2 y, whatever you're comfortable with. So, to begin with, part A, what is the area of the solid formed by spinning this region around the x-axis? Now at this moment, you should try and decide what method you'd like to use to try and find this solid of revolution's volume. You can use method of washers, or you can use method of shells. In most cases, you can use either one. Now, if you're going to use method of discs/washers, your cross sections are going to look like discs/washers. And so each of these will have its radius given by the y value of this green line. So if I used method of washers, the volume would be the integral from the lowest x value to the highest x value of pi times the radius of this disk squared. And the radius is the y value, 2x squared. Integrate that for all the x's from 0 up to 2. Now, I could just as easily do this using method of shells. But I'm going to have to be a little bit careful here, mentally speaking, to turn my thought process around. I'm going to quickly draw this again. draw this triangular region one more time. So here's green and here's red. In this case, filling up with methods of shells means that I will take a line segment parallel to the x-axis, and I'll spin that segment around to get a cookie cutter shaped region, cylinder shaped region, filling up this solid. So then the question would be, what is the surface area? What is the surface area of this cylinder that we just created? Now, the surface area is going to depend both on the height, the distance from rim to rim, height of the cylinder, and the radius, the distance from center to rim of this cylinder. Now notice that the radius in this example is given by the y value of the cylinder that we have drawn, the y value of the cylinder. So using method of shells, the volume would be 2 pi radius, the y value, times the height, Now, let's have a look at this height. The height is given by the difference between the largest x value, x equals 2, and the smallest x value, given by the green line, where x equals 1/2 y. And in order to fill up this region, I would need to take care to integrate from the bottommost y value of the region, y equals 0, to the uppermost y value of the region, the uppermost y value, which occurs when the green line and the red line cross each other. So x equals 2 and y equals 2x implies that the upper limit of this region occurs at y equals 4. So two different integrals corresponding to two different techniques applied to find the volume of exactly the same region.